Okay, so this is like find the derivative type problem.
Yes. Okay.
Okay, so I'll let you. We're so close to exam. We'll just check to make sure you got it here. I would certainly rewrite this if you need to, just as an indicator that it's 1/2 power.
Okay. Let me just get some paper out. All right.
And just let me know when you have your derivative, and I'll write down the answer as well whenever you're ready. How are you doing on this?
I think I got it.
There's two chain rule parts to it. Hopefully you consider that the inside is sine and then the 3x. Are you ready for me to write down the answer?
Yeah.
Okay, so it's 1/2. Keep the inside function and power rules. So you subtract 1 minus 1/2. Derivative of sine is cosine. Keep the inside function, and then one last one. You have to take the derivative of 3x, which is 3. Did you talk to your instructor about simplifying?
Well, on like the one that we did in class, like I can pull it up. I think so. How he wrote it was the final answer 3 cosine 3x over 2 root sine of 3x.
Yeah, and that's like simplified. We can do that if you would like.
Yeah, can we go through that? Because I got up to there.
Sure. So hopefully it's clear that there's a 3 in the numerator, a 2 in the denominator, cosine 3x up here. Now, this part over here, it becomes 1 over sine 3x all to the 1/2 power, and then 1/2 is a root. So that's where it converts to. So you just put whatever goes in the bottom, whatever goes in the top.
Okay.
Okay, let's look at the next one here. I'll snip it in. And the goal here is to take the derivative. Let me write how this could have appeared, so that you see how it may have been written.
Okay.
So that becomes that.
So the number inside, the number under the radical square root is the numerator, right?
Yes, yes. So and I think I wrote this once before. Is like the square root of x to the 1 is x to the 1/2. That's that's probably the best way to remember it if you're ever unsure on an exam.
Third times 2x. Okay, I got it. I think it's 4/3 x squared minus x minus 6 all to the 1/3 times 2x minus 1.
Very good. Okay, so the next one, it doesn't have have instructions. I'll just write the instructions here. Find dy dx, and it's you had some slides that led up to this, so this is something that you would want to be comfortable with. Do you, and do
So
you,
is it just you put the 4 cosine 3t over the 5 sine 3t?
you know, so the, you have to find dy dt and then dx dt. So you treat them independently.
So you find the derivative of 5 sine 3t?
Yes, you do that. Well, that goes on the bottom, and then derivative of 4 cosine 3t on the top.
Okay, so what's the derivative of 5 sine 3t? How do you do that? Isn't it just cosine of 3?
5 cosine 3t times derivative of the inside function.
Oh, you have to do like a chain. Oh, okay.
Yes, yes.
Cosine 3t times 3. So then that's 15 cosine 3t.
Yeah, and then you might get some cancellations, so you might want to hold off on that. What's
Okay.
so the derivative on top? It's 4. Derivative of cosine is
Negative sine 3t times 3.
yeah. So another chain rule. So the 3's cancel. So you get negative 4 sine 3t over 5 cosine 3t.
And then sine over cosine is tangent.
Yeah, and so that let's so let me add a little bit more to this. Let's have you do a tangent line at t equals pi over let me no, that won't work. At pi, let's go t equals pi.
Okay, so you just plug it in
Well,
pi for t.
you need a point, right? You need an x comma y, so you have to go back to use the original, and then you need a slope, which you get from the derivative. So I'm asking you to find x equals 5 sine 3 times pi.
Well, so you just do, okay, yeah. So then that's
So on your unit circle here, 3 pi is going all the way around, and then you go halfway around here. So what's the y value there?
0.
That's sine. So this is 5 times 0, which is 0. And then here it's asking for the x value there. -1.
But the, oh, -4, yeah.
Okay.
But then it's -4.
So then you have to put pi into the derivative because you need to get the slope.
Okay, so then it's -4 over 0, which,
Well, no, it's the derivatives are flipped.
what? You mean by that?
You have to, this is the derivative. It's not the same. So it's -4 sine 3 times pi over 5 cosine 3 times pi.
Wait, how did we end up doing 5 sine instead of 5 cosine?
Sine is the original.
Oh, it's from the original, I see.
Yes, the original gives you the point, the derivative gives you the slope.
The original, okay. So then it'd be 4 sine, so then it's 0. Yeah, 0 over 5 times -1, which is -5, so it's 0.
0. So your equation is y minus -4 equals 0. That's your slope, x minus 0. So this gives you your point. And this gives you your slope.
I led to like simplify the,
Yeah, I mean, this simplifies to y equals -4.
well, to simplify the derivative, so would it be like
It's 0 over -5.
4/5?
Well,
So
no,
would it be like,
it's -4 times 0. So that goes away.
No, like when you're simplifying the derivative, like the sine over, would it be -4/5 like tangent of 3t?
Sure, a 3 pi, or I'm sorry, 3t, yeah. But you don't want to do that when you have, I mean, you could, but then you have to know what tangent is there, and it's like an added
Well, right, but
complexity.
if they just asked you for the
Yes,
derivative, like
yes.
you would want to simplify like that.
Yeah, like maybe back up here.
Right, that's what I mean, not like down below.
Yeah, that would be okay.
Okay.
Do you get any insight onto how much of the unit circle you would be responsible for knowing?
Well, we had a quiz like 2 weeks ago or something, and it was just on the what's it called, first quadrant.
Okay.
So I'm assuming if he puts anything, it'll just be first quadrant.
Yeah. So whenever you see x's and y's together, you're going to do an implicit derivative here.
Do this. So let's.
So let me know when you get that first line down.
Okay. Okay.
All right, let's see here. So 2x plus, now did you treat this as 2x times y or 2 times xy?
2x times y.
Okay, so 2x y prime plus 2y minus 2y power rule y prime equals 0. Is that how yours looks?
I just forgot the two in front of the y. The two. Okay, I got like the 2x y prime plus, and then I just wrote y.
Yeah, the derivative of 2x is of course 2. Okay, so now I'd
Oh,
like you
right.
to,
It's the derivative of 2x, not just x. Okay.
yeah, that's why I asked it that way, because it depends on how you do it. If you looked at it 2 times xy, then then you multiply it in, but you have to decide that in advance. So I'd like you to solve for y prime here, please, and I'd like you to keep y prime on the left.
Okay.
As a,
That's fine. Should do it.
just so we get the same things. Go.
Okay.
All right, so let's see here. So y prime equals, did you go minus 2x and then minus 2y, or which one did you do first?
What do you mean?
Did you subtract 2x and 2y, or like the
Yeah, I
order?
subtracted 2x and 2y.
Okay, so it ends up canceling. There's a 2 everywhere. So minus x minus y over x minus y.
Okay, I didn't know. So can you not
Like you have 2 in front of all these, don't you?
Yeah, exactly.
Yeah, so they all cancel out.
But can it not just like cancel out to -1 then?
No, because if you take out a negative in the numerator, it becomes 2x plus 2y.
Oh, and they're not the same.
Yeah, they got to be exactly the same.
Okay, so it's just x minus 2.
Yeah, I mean it's generally not what you're going to see in this class. It's not like when you were learning about factoring where there's always a problem that reduced to a number. That's not being emphasized here.
Okay.
Okay, so the real question here was, besides just finding the derivative, was to get the tangent line.
Okay.
Okay. Now they give you a point. They give you an X and a Y. So you have to find the slope from this.
Okay,
gives you the slope.
plug it in to the, so that's just negative 2 minus -2. Mm, 6 2. Yeah, okay. And then it's y plus 4 equals 3x plus 2.
Good.
Okay.
Right. So the next kind of page, which I'll snip in, is derivatives of inverse functions. And it seemed like the examples we did were all from a table. Sometimes they actually give you a function for this. So do you want us to do like a function example or a table example, or?
Could we do one of both?
Sure.
Because he said that he will put like a table one on there. But then on the PowerPoint, I think he gave it like a function one. I don't know.
Okay. So it will say something like F inverse of, let's see here, 1 prime, something like that. So it wants you to find the inverse derivative at 1 as an example. So
Okay.
this is like the hardest type because you can't actually find an inverse. So the first thing you do is you find the point, okay, and this number represents y, not x of the original, y of the original.
Right.
So it's where does 1 equals 2 plus 3, 2x squared plus 3x minus 4. So sometimes you have to figure that and the general x values to try are like 1, 0. So when x is 1, it's 2 times 1 squared plus 3 times 1 minus 4. So that's 2 plus 3 minus 4, which is 1. So that's your x value.
Okay.
Now, I've made it easy on you here, like they're both the same, but you know, that's okay. So now, according to this definition up here, okay, you need the derivative of the original. So you need to take the derivative of this thing. So what is the
Okay, so
derivative of?
that's 4x plus 3. Yeah.
Yes, yes. And then you evaluate it at the value of a, which happens to be 1.
Is a the same thing as like x?
Sorry, f. I'm sorry, f. No, not a. It's the other value. So it's this one. This is the one you evaluate at, which happens to be the same, but so it's 4 times 1 plus 3, which is 7, and then that is your derivative. 1 over that is your derivative. So your f
Oh.
inverse of 1 prime equals 1 over 7.
So is your point 1, 1?
Yes,
And
if
then
they ask for that.
okay. Oh, okay.
The table's not as good because I can't make up all these values, but
I think you
so
also gave a function one example maybe on the next page.
those are like trig. So it would say something like f inverse of 2 prime.
Oh, you know why? It's because I sent you the old PowerPoint. Oh,
Okay.
there was a slide missing.
Oh, well, that'd be helpful. If you want to send it over, I get it here.
Okay. Well, we can do that one. No, I'll work on setting it over.
Okay, so the table will have all these other values, but this number, this is the confusing part. It's x of the inverse, but it's y of the original. So you go to your table and you're like, oh yeah, there it is.
So, okay.
So that means your point, I mean, there's your point, -1, 2. So then and so sometimes, so then your slope is 1 over the derivative of the original.
Well, okay, so is the f of -1, 2, is that 2 there? Is that your x value or is that your y value?
It's the x of the original, of the inverse, but it's y of the original. So if you're talking about your tangent line of the inverse, they're actually the same because they're like they use the same point.
Okay.
They touch right there. So it ends up, I mean, it ends up being 1 over -3 is your slope, because that's the only derivative value you have for that x and y value.
Oh, okay.
So then it's, if you need to, it's y minus 2 equals -1 over 3 x.
It's always so it's your basically it's like 1 over the derivative of y.
at that point.
Okay. Interesting. All right. Here, I'm gonna send this over. All right. Okay. I sent you the missing slide.
Okay. Yeah. It's somewhat similar to the one that we just did.
Yeah.
So what I think is, you've heard me say this probably in the past, this is like, you have to guess the x value, which I think is inappropriate in here, because you have to figure this out. And I mean, if you had a graphing calculator, fine, or technology, but you basically have to guess values. So your guesses generally are going to be things like -1, well, could be anything like -2, -1, 0, 1, 2.
Well, why do you have to guess?
Because you need to figure out the x value that turns into that one. See, that number goes right there.
Uh-huh.
So like, what number cubed plus what number squared plus what number doubled gets you back to that?
Oh, get you to -2?
Yeah, yeah. So we're going to try -2. But your guessing isn't as skillful as mine. Why would it be? But you can see here, like, I didn't guess right. This ends up equaling -8. So it's not that. Let's try -1. -1 cubed plus negative squared plus 2 times -1. -1 plus 1 minus 2. So that's it. So your x value is -1. So x equals -1, y equals -2. That's the original.
Could you just set the x squared plus 2x cubed plus x squared plus 2x equal to like 0 and then solve?
If you move that over to the other side, then you have to maybe do some sort of
Well, could you do
factor.
could you do like factoring on the x cubed plus x squared?
Maybe like if it worked out that one time, yeah, maybe.
And then get your x from that, because that would give you the.
Yeah, I mean, this approach over here is the one that I've seen works
Okay.
most. Like, you only ever get one problem on this in this whole course, and it's always one of these values.
So are they just asking you to find the point? I mean,
Well, yeah, because because you have to take the derivative and then you have to evaluate at that x value. So
Well,
that's
we
why you
haven't
got to
done
find.
that yet, right?
What's that?
We haven't done that yet.
No, but that's part, like you don't know what to evaluate it at until you find this x value.
Oh, gotcha. So then you do like
Because you're doing 1 over f prime of that number now. And that's why you need it.
Oh, so then it's 3 times -1 squared plus 2 times -1 plus 2. So then that's.
Yeah.
3.
Yes. So this one just wants the derivative. So the final answer is 3. If it wanted the equation of the tangent line, you could do that.
Okay. So it's like guess and check.
A little bit. So the next two problems here, these are straight from your table of derivatives. And then there's a chain rule part, but like, do you know how much this is going to be emphasized on your exam?
No, I don't know how much.
All right, so let me find a table of derivatives. So your arctangent derivative is 1 over 1 plus, and then it's x squared, but it's this is x, like whatever's in parentheses is x. Do you have that sheet or something like that up?
With like the formulas?
Yeah, like do you know arctangent derivative formula?
No, I can get that on the sheet with.
Yeah. Let me see if I can find one here that will help quickly.
Not on the one that.
Yeah, they're all, there's only kind of one.
What is it? Arctangent?
Yeah, or tan inverse is the way it's usually presented. So let's see here. So here, I mean, here it is. Shoot. Get that out of there. So here it is. That's what I was trying to show you. It's 1 over 1 plus x squared, but
yeah.
x represents whatever's there in parentheses.
Okay.
So
1 over 1
x cubed,
x cubed, yeah.
squared, but then you have chain rule. So what's the derivative of the inside function?
3x
squared.
Yeah, 3x squared.
And you definitely want to simplify this. So like, because you're a good calculus student here. It's 3x squared in the numerator over 1 plus x to the 6th power.
Okay.
Now sine inverse, another one of these lovely ones that only comes up,
Wait, isn't it when exponents are being multiplied that you add them?
You're multiplying the exponents because you're exponent
Oh,
to
because
exponent.
like raised to the second, I see.
Yeah, so sine inverse is 1 over square root 1 minus x squared, but x is this thing. That's your x there. So your derivative is 1 over square root 1 minus 3x squared, but then you have to take the derivative of the inside function, which is 3.
Wait, so your final answer for, sorry, the tangent one?
I'm sorry, yeah.
Was that? Okay.
Yep, this is your final.
Okay, and then the sine one, so then it's 1 over. What was it? 1 over sine root?
1 over root 1 minus x squared.
Oh, so then that's where you, so anywhere there's an x, you just plug in what's inside the
Whatever's in parentheses. Like if it was like e to the x plus cosine natural log of 5x squared or whatever that is, it goes in that position.
3x times 3. Okay. And then, so then it's 3 over 1 minus 3x squared, right?
Yeah, but you should probably square it. So it's 3 over root 1 minus 9x squared.
Oh, do the square, okay.
Yeah, and this comes back again in calculus too, if you end up taking that. These come back again in a pretty important way.
Okay. Is the squared like not connected to the like why is the squares squared in like parentheses? Like why is the 3x in parentheses? Because isn't it like wouldn't it be
So whenever I show substitutions with I always put in parentheses because the square comes before the subtraction operator.
oh okay.
It's order of operations. So that, but if you don't substitute in parentheses, you make mistakes all the time because then you end up writing something like this, and you don't realize that the 3 is squared also.
Oh, got it. Okay.
Okay, can we move on, or is that
Yeah, that's
okay?
fine. Wait, which section would the like the table ones that we were doing yesterday on the AP, what would that like fall into?
Any sort of just generally like derivatives where they give you functions and values of x. So it's kind of like a summary synthesis
Okay.
thing. So this is just another derivative. This is product rule.
Okay.
And again, you have your choice. You're like, you probably want to treat it as 5e to the x as one thing, and go from there. So give yourself like 60 seconds, see if you can work that one out.
Okay.
All right. So based on the way you do it, it's 5e to the x. Actually, don't need this parentheses here. So 5e to the x, derivative of sine is cosine, plus derivative of 5e to the x itself, 5e to the x.
It's e to the
Sine.
x just stays the same, right?
Yes. Okay. Now you could factor out e to the x from both, 5e to the x from both, but not necessary, but you certainly could.
Okay, I got it. I didn't simplify it, but I got it.
Great. So the next one here is, yeah, we'll do this, and then after this is a logarithmic differentiation, which we'll definitely want to cover because it's somewhat confusing first time you see it. So give this one a try here. This is just a chain rule problem.
Okay. Are you supposed to use the 1 over x thing?
Yes,
Whatever?
and 1 over refers to whatever's inside again. So x squared
Then
minus 9.
and then times 2x, right?
Yes.
And then 2x on the top.
Yes. Okay, so we should definitely make sure the next, because it looks like you'll get at least one of these types of the following here.
Okay.
Okay, so there's a rewrite step that you have to do for all of these. And just to be clear, like the one that usually you start with, it's y equals x to the x. That's the one they give you. It's the same way. So the rewrite step here is you take the natural log of both sides of the equation. Okay, and then you use the fact that natural log x to the n equals n natural log of x. Basically, you can move whatever the exponent is, even if it's a function out in front. So on the right, it looks like sine x natural log of x. And all of this is a rewrite that we've done so far. There's no
So whatever the exponent is goes in front.
yes,
Then,
yes,
and then you just move to the ln. Okay.
yes. Now this line right here, you do the derivative implicitly.
Wait, but where did there's only one x, so where did the other x come from?
Which x? There's an x there.
Oh, there's two x's. Never mind. You're right.
Okay. So on the left side, just I know I'm saying a lot here, but the left side is always the same because it's always the natural log of y. So the derivative of natural log of y is 1 over y, but because it's implicit, there's a y prime here. 1 over y, that's the natural log of y. So if it's natural log of x, it's 1 over x, but then you throw in the y prime. Is that okay?
Okay, yeah.
Okay, now on the right, it's product rule. So give that a try on the right.
Isn't it 1 over? Oh, but it's ln y. Never mind. Okay. So that's sine x. Plus x. Okay, sine x times 1 over x plus ln x times cosine x.
Okay, that looks good. Okay, now on the left here, this is rewritten as y prime over y. And then over here, we'll just clean this up a little bit. So it's sine x all over x plus natural log of x cosine x. Okay, now you're not done because you're trying. Your goal here is to solve for y prime. So how do you get y prime by itself? Well, you multiply everything by y.
Okay.
So if you multiply everything by y, and we'll do it for this problem so you can see this really clearly, but it's the same. Those y's cancel.
Because y, you're multiplying by y because y is on the denominator here.
That's right. Okay. And then so on the left, you just have y prime. On the right, instead of writing y, you go back to whatever y was when you started. So this y right here becomes, go back up and look for it, x sine x.
Oh, dang, that's so confusing. Okay.
Okay, but it ends up being the same every time. Like you always multiply by y. The left side is always y prime over y. Okay, and it's always something in parentheses times x sine x.
Can you just leave it like that? Oh,
yes,
yeah.
yes,
Okay.
yes.
I was like, Jesus, you have to go through it.
Well, I mean, there's more reason. Yeah. So the easier one, and this may be your test question, is y equals x to the x. And it'll say,
will it just say like find the implicit derivative? Or
no, it'll just say you find the derivative, but it might say use logarithmic differentiation. Because that's what it says in your notes, but
is logarithmic I don't know how to say that word. Differentiation, just like
It means take the ln of both sides
Okay.
and go from there.
So then ln y ln.
So you have to get it to this third line where it's all in line here, no exponents. Okay, and I want you to take it from here. I want you to, on the left, take the derivative. That's implicit. On the
Okay.
right, it's product rule. It's always product rule on the right. It's always implicit on the left.
X. Oh, yeah. So x minus 1 over x. X, and then times y. Okay, so
let's just check this line here. So x times 1 over x plus natural log of x times 1.
yeah, I got that. So then what do you do with so then it's like y prime equals all that because you multiply by y.
Yeah.
But then
Well,
like what do you?
so well, I mean, let's go a little slower because I don't know if you simplified this or not.
No,
It's
that's
good.
what I'm confused. Like, what do you do with that?
Well, you have to solve for y prime, but you don't need to do it all at once. You got to, clean up the right side first.
Okay.
So when that's cleaned up, like x over x is 1, the natural log of x times 1 is natural log of x. Then you multiply both sides by y. So your y prime equals 1 plus natural log of x times y. And from the original, y was x to the x. So
then
this goes there.
X to the x times 1 plus ln x.
Yes.
Okay.
And it's always that way. It's always the original times something.
Okay.
All right. Let's do the last one. I'll have you do the last one here. All right. So I'd like you to try this one on your own. It's just like the last ones, although I guess it's slightly odder because it's got the ln and the exponent, but.
So x 1 over x y 1 over y prime. That's 1/2.
So the left side always becomes y prime over y.
Yeah, I'm at that step right now.
It's one of those steps where it's like you may just want to remember that too.
Sorry.
No problem.
Okay, so so y prime over y equals 2 ln x times 1 over x. That's where I am.
Right. So they just simplified a natural log of x over x, natural log of x over x.
Wait. But I had a 2.
I wrote a 2 accidentally. I'm sorry. There's really 2 of these here. Like these together make 2. Like here's 1, here's another, but they're both natural log of x over x, natural log of x over x.
So then would it be 2
Natural log of x.
ln x over x?
Yeah, and I'll try.
Then
Then you got to multiply by y.
and then you put in back in the whatever the original, what was it? X ln x. Right?
Yes. Yes. So your final answer will look something like this. Something like that. You will get one of these according to like what I'm seeing. So although it wasn't on the review, but I mean, it's totally reasonable if they're asking you to do this.
A little confusing, but I'll do some more practice ones.
Yeah. Now, really quickly, if I said y equals cosine cubed 5x plus natural log squared of I don't know 10x to the 5th. These 2 and 3s, these are power rules first. If you were to find y prime, I didn't know if that was covered or clear. This is just notationally how you write it, but there's kind of this intermediate step to write if you want. It's cosine 5x cubed plus natural log 10x to the 5th all squared. Like, yeah, and it's
so why don't they write it after like the 5x?
Because that's different.
Oh.
If you put the 3 here, it means you cube this inside part first, then you take the cosine of it.
Huh.
So it could be a little, it could be a little bit.
You would do product rule, or no, you would like bring the 3 down, so it'd be like 3. What would you, are you trying to find the derivative?
Yeah, it's everything's derivative. So it's power rule first, 3 cosine 5x squared. Then derivative cosine.
Negative sine
5x. And then you have to take the derivative of 5x, which is
5.
Now this plus is that one.
So then plus 2.
Natural log 10x to the 5th to the power of 1 if you want. Then what's the derivative of natural log?
1 over x.
1 over 10x to the 5th, because that's the inside function.
Times 10.
Times the derivative of 10x to the 5th.
So 50x. Yeah.
Yes.
Wow. Would you have to simplify that?
Only if they asked you to. So again, like the instructions will generally tell you do not simplify. If it doesn't say, then you should assume that you should.
Okay. So if it's okay, so they're just bringing it out to the bins. Okay. So
Yeah.
It's everything is like cubed in that case. It's not just.
Yeah.
Okay.
Yes. Okay. Any final questions here? Any lingering questions? Like,
I think that's it. Okay, I think I'll just do some more practice, and that's everything.
all right. Well, I think you're more prepared than ever. So I wish you well on this, and thanks again for scheduling.
Thank you.
I'll send you the notes right away on this
okay,
one.
perfect. I was just gonna ask.
All right. Have a great night. Bye now.
Thank you, you too.